This video is meant to be a quick review of the statistical tests that you need to know for the IB Math Applications and Interpretation exam. And they are the chi-square test of independence, the chi-square goodness of fit test, and the two sample t-tests. So the first one that we're going to go over is the chi-square test of independence. I feel like this is by far the easiest one. I call this the cookie cutter test because to state the null hypothesis and alternative hypothesis, you basically just stick to the script. So in order for you to write the null hypothesis, you're going to say that variable 1 and variable 2 are independent. And you're not going to write down variable 1 and variable 2. You're actually going to write down whatever it is that the problem is about. For example, if they give you a problem on whether or not there is a relationship between ethnicity and seatbelt usage, you would say that the null hypothesis, which you would write down as H naught, is that seatbelt usage and ethnicity are independent. Then the alternative hypothesis, which you could write as HA or H1, would be that ethnicity and seatbelt usage are not independent. Okay, so it's very easy because whatever the two variables they give you for the null hypothesis, you would say that they are independent, and for the alternative hypothesis, that they are not independent. Now, the observed frequencies are going to be given to you. They could be given to you in a chart. Sometimes the chart gives you the total, sometimes it doesn't, so be very careful with that. Then from there, you can find what are called expected frequencies. I'm going to show you how to put this into your calculator into the matrix, and then I'm going to show you how the calculator will give you these observed frequencies. However, there are sometimes show that questions on the exam that require you to actually show the work for the expected frequencies. And the way you do that is to multiply row total by column total and divide it by the grand total. This is not a formula that's on the formula packet, so it is something that you would have to memorize. So expected frequencies is row total times column total divided by grand total. And in case you have forgotten, rows are left to right, columns are up and down. So in the graphing calculator, which again, I will show you when we get to an example, you would have to go to matrix, which on the TI-84 Plus is second x to the -1. You would go to edit, you're going to enter the dimensions of the matrix, and then that's how you're going to basically enter the observed frequencies. Once again, in show that questions, you cannot say that you got the expected frequencies from the graphing calculator. You actually are expected to remember that it is row total times column total divided by the grand total. Then for degrees of freedom, again, when you run the test on the calculator, it will give you the degrees of freedom right away. In the case that you have to show the work for degrees of freedom, simply what you have to do is take the number of rows -1 and multiply to the number of columns -1. Then we are ready to get to our conclusion. Our conclusion can be done two ways. One is to compare p-value to the significance level. The significance level will be given to you on the exam. It is either 1%, 5%, or 10%. Or you can actually go ahead and compare what's called the chi-square calculated value to the chi-square critical value. You have to keep in mind that the critical value comes from a chart. They're not going to give you this chart on the exam. So if they do want you to be able to make a conclusion where you are comparing chi-square calculated to chi-square critical, they would have to give you that critical value. This isn't something that you're going to memorize the entire chart. It's crazy to do that. So if they give it to you, then that's a green light that you can find the chi-square calculated value from the calculator to compare to the critical value. However, I know that in years prior, they put more emphasis on p-value because students have a harder time with p-value. So p-value gets compared to significance level. And in the calculator, you're going to go to Stat Test, option C, which is the chi-square test of independence. What conclusion do you reach? Well, if your p-value and in a chi-square distribution, you have to understand that the graph can look something like this. And so right here is my cutoff. All of this would be, for example, shaded, and depending on the chart or the graph that you work with, sometimes it's done a little bit differently, but for the ones that we're working with right now, it is safe to say that this is going to be our critical value or our significance level. So this could be the chi-square crit, or it could be basically our significance level, which again, it's going to be given to you either 1%, 5%, or 10%. If the p-value, and p-value basically just stands for area under the curve. So when they talk about p-value, think of it as the area under the curve that is going to be shaded, where the whole entire curve represents 100% or 1. So when p-value is less than the significance level, it falls in this unshaded region, which is called your rejection region. This is a review. If you need to go back to actually learn all of this from scratch, there are other videos that I have, but this is for those of you who are just reviewing this for your exam. So the p-value is area under the curve. If the p-value is less than your significance level, this is when you're going to reject the null hypothesis. It is always accepting or rejecting the null hypothesis. And so if you reject the null hypothesis, you would conclude that variable 1 and variable 2 are not independent. Instead of saying accept, in statistics, it is better to say you fail to reject, but they will take accept. So if that's how you want to memorize it, that either you accept or reject the null hypothesis, then that's kind of like how you're going to do it. For critical value versus calculated value, it works like a number line. So if the critical value is right here and the chi-square calculated value is greater, that's when you reject the null hypothesis. So if the chi-square calculated value is greater than your critical value, that is when it falls in the rejection region, and that is when you're going to reject the null hypothesis. Otherwise, if the chi-square calculated is less than the chi-square critical, you would fail to reject or accept the null hypothesis. So let's go ahead and take a look at an example. This example is actually from the November 2021 paper 2 time zone 1 test. It says a group of 1280 students were asked which electronic device they preferred. The results per age group are given in the following table. A student from the group is chosen at random. Calculate the probability the student prefers a tablet. So notice that before we get into the whole entire chi-square test of independence, they're actually going to have us answer these probability questions. So this is also a really good review of basic probability. In this case, you want a random student. There's a total of 1,280 students here. How many of those students prefer a tablet? You would have to find tablet. The total amount of students that prefer a tablet is going to be 560 out of 1,280. And you can leave your answer as an unrounded fraction. That actually is what I tell my students to do, because that way they get your thought process. And sometimes if you just write down a decimal and let's say you made a mistake, then it's kind of hard to track what it was that you were in fact dividing. If you want to write a decimal, then you can go ahead and just put equals and then write down the decimal value. Sometimes if they ask you for a percentage, of course, go ahead and divide the two numbers, multiply by 100, but always show your work before. So always show the fraction that's not reduced as part of your work. For part 2, it says calculate the probability the student is 11 to 13 years old and prefers a mobile phone. So in this case, we're looking at all the students that are 11 to 13 and prefer a mobile phone. So that means that we're looking at 72 students out of a total of 1,280 for my answer for part 2. Then in part 3, it says, what's the probability that the student prefers a laptop given that they are 17 to 18 years old? In probability, when you have a given condition, it is going to affect your denominator, because now we know that the student is 17 to 18 years old. That is a given condition. Therefore, I am only looking at the 348 students that are 17 to 18 years old. And out of those 348 students, so that becomes my new denominator, how many of them prefer a laptop? So the answer is going to be 153 out of 348. Last but not least, what is the probability that a student prefers a tablet or is 14 to 16 years old? One of the things that you have to worry about this problem is not to overcount. You want to look at all the students that are 14 to 16 years old. And you can think of this as saying that's 512 students. Then how many of those are going to prefer a tablet? We have a total of 560 students that prefer a tablet. But if you notice, when I circled, okay, I circled it here to include all of those, and I circled right here. So notice that this number 224, they both have in common, so I cannot overcount. One of the biggest things about probability is that you cannot overcount. So I'm going to subtract that 224, and then this is going to be all over 1280. So you would have to take your calculator, and you would have to add 512 plus 560, and then subtract 224, and you're going to get 848 out of 1280 as your final answer. The other way that you could have done this problem is to literally said, okay, how many students prefer a tablet? These students prefer a tablet, these students prefer a tablet, these students prefer a tablet. And then how many of them are 14 to 16 years old? You're going to add the 160 and the 128. And then if you were to add up all the numbers that I have just circled, you're going to end up with exactly the same answer as we did when we added the two totals and subtracted what they had in common. 848, and this is a probability question, so it's over 1280. Okay, so now we get going with the chi-square test for independence. It says, a chi-square test for independence was performed on the collected data at a 1% significance level. The critical value for the test is 13.277. So in this case, they are giving you the chi-square critical value, which is going to be 13.277, which means that it is going to be okay for me to compare that to the calculated value to reach a conclusion. So the first part says to state the null and alternative hypotheses. Take a look at what we're talking about. It says a group of 1280 students were asked which electronic device they preferred. The results per age group are given. So we are looking at age versus the preferred device. And that's literally what you are going to write down. So the null hypothesis is going to say, I'm going to write it here because there's very little space because this is a paper 2 question, which means that you would answer all of this in your own answer booklet. The null hypothesis is going to be that age and preferred device are independent. And it doesn't matter which order you write the two variables in, because it doesn't matter if you put preferred device and age are independent. Then the alternative hypothesis is going to say that age and preferred device are not independent. Can you write are dependent, since dependent is the opposite of independent? They will accept it. You will get points for it, but it's better to say that they are not independent. So the other thing is, don't be lazy. Actually write down the two variables instead of just writing they are independent, they are not independent. So then from part C, it says to write down the number of degrees of freedom. So degrees of freedom is equal to the number of rows minus 1 times the number of columns minus 1. Rows go left to right. So here there's 1, 2, 3 rows, and then there's 1, 2, 3 columns. Be very careful not to include the totals in these counts of columns and rows. That is one of the biggest mistakes you could possibly make. There are times where they don't give you the totals at all, and then you would have to find them yourself. But this is a 3 by 3 matrix. There are 3 rows and 3 columns. So in order for me to find the degrees of freedom, it is going to equal 3 minus 1 times 3 minus 1, which is 2 times 2, which is equal to 4. So the degrees of freedom is equal to 4. Then we go on to part D. In part D, it says to write down the chi-square statistic. Anytime on the exam it says write down, it means that it should be something that's very simple. It should be either right in your face in the problem, or it is something that you can get very easily from the calculator, which means that at this time, we are ready to enter this into our calculator to figure out our answer. You're going to go to second x to the negative 1, which is matrix. You're going to go over to edit, and you're going to press enter. In this case, if you remember, this was a 3 by 3 matrix. So I'm going to put 3, enter, 3, enter. Notice the space is going to open up. In this case, it's easy because even if you confuse rows and columns, it's still going to be 3 by 3. Let's say that this were a 2 by 3 matrix, but instead you put 3 by 2. You're going to realize that the space that is opened is not going to match. So just switch them around. It's not that big of a deal. So I'm going to go ahead and enter the data. It was 143, press enter. 160, press enter. 153, press enter. 205, press enter. 224, 131, 72, 128, and 64. And you are going to trust what the calculator is going to spit out as the answer. So it is very important that you take about 5 seconds to look at the data again and make sure that you have entered it correctly. So that is something that's very important for you to do, especially when you're testing. So now I can go to stat, go over to tests. It's actually faster to go up than it is to go down. I'm going up to choose C, which is the chi-square test of independence. Press enter. It's going to ask you, where is the observed data? It's in matrix A. Where is the expected data? You can go ahead and put it in B. That's fine. Leave it by default. And then go to calculate. Press enter. So the calculator now has given you the chi-square calculated value of about 23.3. It's giving you a p-value of 1.09 if you round to 3 significant figures times 10 to the negative 4. Take a look at p-value on the screen. Do you see the e to the negative 4 at the end of that number? That means that needs to be written in scientific notation. It means times 10 to the negative 4, and also the degree of freedom is equal to 4. So when I go back to the problem, I already can get the answer for part 1 and part 2. For part 1, it says write down the chi-square test statistic. And so here the chi-square calculated value is approximately 23.3. But I always say it's a good idea to write down all of the calculator values. And then at the end, you're going to round to 3 significant figures because sometimes my students have a hard time rounding. And then for part 2, it says to write down the p-value. Same thing, it's 1.089910025 times 10 to the negative 4, which is approximately 1.09 times 10 to the negative 4. You cannot write E as your answer because you're not going to get the credit for it. And if you remember, the degree of freedom is equal to 4, which is exactly what we got when we did it by hand. So now we are ready to do part 3, which is to state the conclusion for the test in context and give reason for your answer. Okay, so now in order for me to do part 3, which is to state the conclusion, I actually have a choice. Because I figured out the chi-square calculated value, I can say that since the chi-square calculated value of 23.3 is greater than the chi-square critical value of 13.277, remember they gave us that in the problem, then because chi-square calculated is greater than critical, we reject the null hypothesis. So we conclude that age and preferred device are not independent. And that is because we rejected the null hypothesis. If, let's say, hypothetically, the chi-square calculated value would have been less than the critical value, then we would have failed to reject the null hypothesis and concluded that age and preferred device are independent. So if you are failing to reject, that means you're accepting the null hypothesis that the variables are independent. But if you are rejecting the null hypothesis, then you basically say that the variables are not independent. There's another way that you can do this, and that is to compare significance level to p-value. So I'm going to go ahead and notice that I erased just the actual result part. The conclusion part is going to stay exactly the same. So since our p-value of 1.09 times 10 to the negative 4 is less than our significance level, which in this case they told us was 1%, 0.01, then we still reject the null hypothesis and conclude that age and preferred device are not independent, and then that's how you do this problem. Okay, so let's go ahead and try another problem. This one is from the November 2017 paper 1. In a school, students in grades 9 to 12 were asked to select their preferred drink. The choices were milk, juice, and water. The data obtained are organized in the following table. So this is a paper 1 test. So notice a chi-square test is carried out at a 5% significance level. They've already given you the hypotheses. In this case, the null hypothesis is the preferred drink is independent of the grade, and the alternative hypothesis is that the preferred drink is not independent of the grade. They did also give us the chi-square critical value for this test, which is 12.6. And now it says to write down the value of x. So let's go ahead and look at the chart. Here's x right here. So our job is to figure out the value of x. Of course, one of the ways we can do this is to add up all of these numbers right here, 31 plus 13, and subtract from 74. Or I can go ahead and use the column total, and then I can go ahead and add 34 plus 35 plus 36 and subtract that from 135. So you have a choice. It doesn't matter which way you do it. You're still going to get the same answer. Because I find it shorter to just subtract 74 minus 31 minus 13. That's what I'm going to do. So 74 minus 31 minus 13. That means that x is going to equal 30. Write down the number of degrees of freedom for this test. Okay, so if we take a look, we have 1, 2, 3, 4 rows. So we have 4 rows, and then we have 1, 2, 3 columns. Okay, so that means that this is a 4 by 3 matrix when I enter it. To figure out the degrees of freedom, I simply need to do the number of rows minus 1 times the number of columns minus 1. This is 3 times 2, so the degrees of freedom is equal to 6. One of the things to notice is the number of points, the number of marks each question is worth. Any question that's worth 1 mark, honestly, you're not going to get any credit or get penalized for not showing work. They just want to get your answer, and that means you're either going to get it right or you're going to get it wrong. So you could get this straight from the calculator. It will tell you the degree of freedom is equal to 6 and just write it down. Then it says to use your graphic display calculator to find the chi-square statistic for this test, which means that we have to go back to our calculator, to the matrix, and enter this ourselves. Okay, so in the calculator, we're going to go back to second x to the negative 1. We're going to go over to edit, press enter. In this particular case, we said this is a 4 by 3 matrix. Notice how it opened up another row for us. So now I start 25, 34, 15, 31, x, which is 30, 13, 18, 35, 17, 9, 36, 26, and now I've entered all of my values. So now we go to stat, go over to tests, go up to chi-square test of independence, then press enter, 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 and you're going to get your chi-square. Calculated value is 18.96, so about 19.0 to 3 significant figures. The p-value is 0.00422 to 3 significant figures, and degrees of freedom is equal to 6, which is exactly what we got when we did this problem. So when we go back to our work, I want to write down the entire answer for part C, which is the chi-square statistic is 18.964055758, which is approximately 19.0 to 3 significant figures. And I always like to write the entire answer down. In case you make a mistake, they know that you did get exactly the right answer. Then to state a conclusion for this test, you could say that since the chi-square calculated value of 19.0 is greater than the chi-square critical value of 12.6, then we reject the null hypothesis and conclude that preferred drink is not independent of the grade. And that's it. That's our answer. Because we did find the p-value, you would have still gotten credit if you would have written that since the p-value, if you remember, of 0.00422 is less than your significance level of 5%, which is 0.05, and then the same thing will hold true. Then we reject the null hypothesis and conclude that you would just say the same thing that we already wrote. Preferred drink is not independent of the grade. You only want to choose one way of writing down your answer. For the IB exam, they will take your first answer anyway. So let's say that you put both of them down because you're not really certain what they want. They're only going to look at the first one. Sometimes they are very specific and they will tell you using p-value or using the chi-square calculated value test statistic. But if they don't, then you have a choice. And of course, there are going to be times they don't give you the critical value, in which case then you have no choice than to only use the p-value for your answer.